Galitskaya. I'm an antenna engineer who really loves simulation. Most of you know tools like HFSS, CST, FEKO, but there is a new tool now that caught my attention called Nullspace. To give you a first look, I've invited Masha Petrova, who is CEO of Nullspace, to tell you more about the tool. Hi, Masha. Thank you that you joined me today. And can you introduce yourself for my audience?
Hi, Katerina. I'm so excited to be here. Thank you for inviting me to speak with you. Yes, my name is Dr. Masha Petrova. I am the CEO and co-founder of a company called Nullspace, which we'll be kind of talking about today. My background is actually not electromagnetics or RF. It's aerospace engineering, but I had a lot of experience with various simulation tools, specifically on chemical kinetics. My PhD was doing research in combustion. Funny enough, I thought I'd get to burn things, but I mainly sat behind the computer and simulated things.
Yeah, disappointment.
Yeah, I mean, I wouldn't say this, but I still enjoyed my work quite a bit, but it definitely didn't get to burn anything.
Yeah.
And so after my work in grad school, I went to work for a small simulation startup that was simulating one-dimensional reactive flows, and that little company then got acquired by ANSYS. And after that, I tended to have a history of working for startups that would then eventually get acquired by ANSYS. Now, of course, this has been acquired by Synopsys, and so at this point, everything on my resume has been acquired multiple times. And so I spent a lot of time in simulation, and I came to Nullspace because the code itself was actually developed in stealth in a company called Iris Technologies. They're a defense contractor based in Huntsville, Alabama. The two co-founders are super smart, and they have extensive background in electromagnetics and computational electromagnetics, hardware and software. And they were ready to sort of spin out this code that they've been working on for over a decade into a company. And they were looking for a CEO who had experience in marketing and sales, but also understood simulation. As you can imagine, that's a hard combination to find.
Yeah.
But
how did you kind of get the courage to go into this? Okay, it's simulation, but it's completely different field, right? As you said in the beginning, like how did you end up joining Nullspace and decided that this is the way?
Yeah, I actually I applied on LinkedIn, by the way. They did not see my application. So for those of you applying on LinkedIn, find a connection, join connection. So I found one person who was actually he's a salesperson at Altair at the moment, which is funny enough because Altair is a competitor now. And he introduced me to my co-founders and told them, "Hey, this lady is bothering me and saying that she applied to your CEO role. Can you like take a look at her resume?" And so the rest is history. But I think I've been in, I believe, 8 or 9 companies, including public companies like ANSYS, like a company called Altium, those of you familiar with Altium Designer, MSC Software, which then became Hexagon, which is now becoming Cadence, which was another acquisition. And so I've oversaw a number of different simulation tools when I was running global marketing at MSC Software. I think at one quarter, I launched 16 different products, meaning I didn't launch them myself, but I was responsible for the marketing campaign, 16 different products, which included Mark, which was a nonlinear FEA tool, included additive manufacturing tool. It included like a forging and metal forming software tool. These are all software tools, but they were completely different applications. There was a CFD software tool that they were launching as well. So I got to experience all these different tools. And then I was in 3 different startups. That one was a multi-physics simulation software, which was acquired by ANSYS. One was additive manufacturing simulation tool, which was acquired by ANSYS. And of course, my very first foray into the space was a company called Reaction Design, which was also acquired by ANSYS, which was on 1D simulation, like I said, of reactive flows. And so I saw a lot of tools, and I saw that there's definitely a common thread throughout all of them, right? And that is that you're taking physics that was described by some complicated set of governing equations, whether it was Navier-Stokes, Maxwell's equations in our case now, whatever it is, right? So there's a set of governing equations and they're hard to solve in your head. And so you take them and you code them into computer code, or you convert them to linear algebra, and then you solve that linear algebra with computer code. And that's essentially sort of like a big umbrella of how simulation tools work. And understanding that kind of helped me dive into various tools. And again,
Hmm.
I'm not developing them. I'm in charge of the marketing and the sales and how do we bring them to engineers. But because I have an engineering background, it's really important for me that the type of marketing that we do is sort of respects what the engineers need. And it's not just fluffy garbage AI generated words.
Yeah, exactly.
Right?
Yeah, I think it's always great to have like technical background, and I think that it's much more valuable when like you in all position, not only in technical positions, you have people that actually understand the technical background. But I was kind of curious. You said that you have like you have so many companies in your resume, right? There's so many startups and so how is Nullspace is different from your perspective? How could you describe the company for
Yeah.
new users?
So, yes, great question. Well, first of all, it's a company that I now run, which so I have a special affinity for it. But I think one of the
Right.
reasons, if you ask like, oh, well, how were you able to actually join it as a co-founder? When we started, it was just me and my two other co-founders. We were teeny little team with this technology that was really valuable. And so I think because I've seen so many simulation tools and because I've been on so many sides of acquisitions where I was running marketing, either at a large company that was acquiring a small simulation company or at a small startup simulation company that was being acquired by a larger company. I've seen kind of like all the dirt, all the ins and outs of what can hide underneath a complicated tool. And I kind of developed an eye for seeing what's actual valuable simulation tool and what's sort
Yeah.
of fluff. And so when I saw what these guys were developing and kind of saw the history, heard the history behind Nullspace technology, and it was very clear to me that this was a real valuable tool that just happened to be hidden and developed in stealth in this DoD contractor for a decade. And so what makes it different? So number one, it's a full fidelity electromagnetic simulation tool, meaning we're not approximating anything. We're not using any kind of AI generated data. We're solving, Maxwell's equations using method of moments 3D full wave solver, right? But what's different is this is a modern implementation of the method of moments method to simulation. So unlike some of our competitors, which you've mentioned in the beginning of this video, which are other full fidelity simulation electromagnetic tools, Nullspace is much faster and it's designed to be much more flexible for things like when you need to set up loops of simulations. So whether you're doing uncertainty analysis or any kind of like Monte Carlo analysis or anything where you need to be running the simulations on repeat and tweaking things in between, because of our Python API and how the tool is set up, it's really developed for these really complicated simulation workflows, right? And because it's method of moments, modern implementation, there is a compression algorithm in the tool which compresses the metrics on the fly in a certain way, as opposed to some other compression methods. And we have CPU and GPU acceleration. It's a direct solver application and so on. Because of all these things, two things happened. One, the solver is much faster than any of the legacy tools without sacrificing accuracy. So you could still rely on your results. There's still full fidelity, full accuracy results. In some cases, we found were actually more accurate than some of the more common tools that people have been using for decades now.
Mm.
But we're faster. And so specifically in the areas where the problems are electrically large and some of the current, again, tools that we've all used, they just can't handle them. Even if you put it on a really large machine, it's still, the machine scales, but yet those solvers are not able to scale, which makes sense if you think about it. Like, let's say a tool like HFSS has been developed something like 40 years ago. The solver itself has been developed 40 years ago. And think about the computers that were around 40 years ago,
Yeah.
right? And so, there's no way the developers of those tools could have predicted what the machines or computing architecture would look like nowadays,
Mm.
right? And so that's what makes Nullspace different.
Yeah. I think it's a usual struggle for engineers to have like both detailed design and speed, right? You usually choose one or another. That's kind of how it is always for us. We either have accuracy, like the biggest accuracy that we can get, or we have speed.
Right. And I mean, not to talk down on the current tools that are reliable, say, workhorses of electromagnetic simulation software, right? Because they certainly very much have their place. Something like HFSS, can solve a variety of problems across the spectrum on the simulation side of things, right? Like from stuff on the board to larger simulations. But it's when you start to move into like the simulation of systems, like let's say you want to simulate how your antenna is going to act in an actual environment. So
Exactly.
not in isolation, but you want to see how it's interacting with the environment. Or let's say you have multiple antennas on a large body. So that could be, I don't know, what would have a lot of antennas on a really large body, a spaceship.
Yeah, it's or like base station antennas, right? On these masts.
Yeah, exactly. I mean, I don't have to tell you about antennas. You should you should actually be telling me about antennas. But yeah, so once you start getting your problem starts to get larger and larger, what we hear from our customers is that they have to then approximate one way or the other. So like the HFSS or CST will only carry them that far, and then they have to start chopping the problem into pieces, and then you're losing accuracy, right? And so now, again, as you probably know, as your audience knows, with everything being connected with everything and more antennas being on everything, the problems are only going to get larger. They're not getting any smaller on the electromagnetic side, right?
No, they're not. So that's true, and that sounds really exciting for me, actually. And so I'm just wondering for my audience, if an engineer watching this right now and they want to learn this tool, which sounds very, very exciting and very useful, what is the best way to get started?
Yeah, great question. So our website is nullspaceinc.com. We're actually revamping the website and are hoping to add more resources on there. There is a resource page that includes a couple of customer success stories, some tutorials and things like that. So nullspaceinc.com is the website. We're on LinkedIn, obviously, also Nullspace Inc. on LinkedIn. Our YouTube channel, also Nullspace Inc., has some tutorials in it and a number of videos. And we're excited to have you join our YouTube video community, right? Do you want to talk about that?
Yes, so I am super excited to start learning new tool. I really like learning new things, and this tool got really my attention. So I am, as a new user now, will learn this tool and document my experience, and I will share these tutorials that I will create with my audience, and I hope that it will be really interesting. Thank you very much, Masha, for being with me today. I'm really excited to continue this journey and document my experience with Nullspace. I hope that my audience got a good hint about Nullspace now, and I thank you for having time with me today.
And we're thrilled to be working with you. Thank you.
Thank you. Bye-bye.